One of the most hotly contested procedures during the Apollo missions was how NASA dealt with the issue of the Van Allen belts, the naturally occurring belts of radiation that surround the Earth, both on the journey to the Moon and also returning from it. To some, this just proves the point that NASA never went to the Moon because they contest that if a crew went through the Van Allen belts, they would have received a lethal dose of radiation and died during or shortly afterwards. But as we know, that didn't happen. So how did they achieve this? Mention the word radiation and most people will think of X-rays, the atom bomb, Hiroshima, Chernobyl, and therefore associate it with bad things. Yes, you do need thick lead shielding to protect against high intensity X-rays, but the radiation in the Van Allen belts is not X-rays, it's charged particles. There are two main types of radiation. The first is electromagnetic waves. This covers everything from radio waves through microwaves, infrared, which we feel as heat, visible light, on through ultraviolet light, onto X-rays to gamma rays. That is the electromagnetic spectrum. The second type of radiation is charged particles. These are the component parts of atoms such as protons, neutrons and electrons, which have been broken apart by nuclear reactions or extreme heat in the sun. These particles flow out from the sun as the solar wind, and because they have a positive or negative electric charge, they react with the Earth's magnetic field. Some are attracted to the north and south poles where they enter the atmosphere and react with the air to create the northern and southern lights. Others are captured into the bands of the magnetic fields around the Earth where they form the Van Allen belts. These consist of an inner and outer belt and a temporary third belt which appears when the sun has large solar flares. These bands extend from between 1,000 and 60,000 miles above the Earth's surface, with the most active areas centered around the equatorial area of the Earth, but thin out nearer the poles. This type of charged particle radiation is also known as ionizing radiation, which means that it has enough energy to knock electrons from atoms or molecules that make up the spacecraft and the crew inside, which can cause tissue damage if there is a high enough exposure for long enough. The main types of ionizing particles in the Van Allen belts are high-energy protons and electrons. The protons can be stopped by light materials such as the aluminium skin of the craft and also the epoxy resin heat shield. Electrons, which are also known as beta particles, can penetrate several inches into living tissue, but because they're very small, they don't tend to do much damage. They can also be blocked by materials like polyethylene, which contain a lot of hydrogen. The hydrogen atoms are very light and absorb the beta particles, as well as the fibrous insulation material that was fitted between the inner and outer hulls of the command module, which would also have been a good shield against them. One problem is that when beta particles interact with large atoms like lead, they give off secondary X-rays, and this is called the Bremsstrahlung effect. So the thick lead shielding that some people think is needed to protect the crew against X-rays would ironically make the problem worse by creating more X-rays, whereas the lighter metals like the stainless steel and the aluminium of the command module would create less X-rays, and even then some of the X-rays would be absorbed by the inner hull. So whilst we can shield against the radiation to a degree, providing it's not too strong, there are other things that the NASA engineers and the mission planners knew about, and one of these was where the thickest and most lethal parts of the Van Allen belts were, and also how the human body reacts to radiation. The effects of radiation are cumulative, which means the longer you're exposed to it, the more damage it causes. Within reason, a short exposure to higher levels of radiation is better tolerated by the body, as it has time to repair the damage afterwards. Long exposures to low levels of radiation cause more problems because the body has to try and repair itself and contend with the continual damage whilst it's doing this. If you spent an extended period within the Van Allen belts, then the effects would be lethal, but the Apollo crews only spent about 6 hours in total, around 3.5 hours going and 2.5 hours returning several days later, effectively 2 short bursts separated by a rest period. More importantly, the course which each of the Apollo craft took avoided the most lethal parts of the inner belts completely. and they only went through the thinnest parts of the outer belt. All the astronauts wore dosimeters to measure their personal radiation exposure levels during the flight and reported results back to NASA at regular intervals. In total, the amount of radiation that the Apollo crews received during their flights to and from the moon from high-energy protons, electrons and X-rays from the Bremsstrahlung effect was much less than that of the yearly allowed dose for someone working in the nuclear industry and regularly dealing with radioactive materials. In the end, the simple answer to why the Van Allen radiation belts were not the killer issue that some people think it was, and how the Apollo missions cut the radiation exposure for the crews to between just 1 and 5% of what it could have been, is because the Apollo missions didn't need to go straight through the Van Allen belts. They basically flew around the most deadly areas and were not in the less dangerous areas for long enough for it to be a showstopper. This remains true today as it is for any future missions. Why go through it when you can just go around it? Thanks for watching, and I hope you found it interesting and informative. If you did, let me know in the comments below, and as always, please subscribe, rate and share. We also have other videos that you may find interesting on the Click More Videos link above, now showing. So it's goodbye from me, and I hope you drop by again soon.